Hello students, now we are solving question number 4 of exercise 5.3. Question is, how many terms of AP? AP is given to us, that is 9, 17, 25 dash 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 must be taken to give sum as 636. First try to understand what are the given values. Given is A, that is 9. Difference can be calculated as 17 minus 9. Now Sn, that is 636. We want to find value of n. Now simply we are using formula for Sn, that is n by 2 in bracket 2a plus n minus 1 into d, that is 636 already given to us. Simplify this, we are getting one quadratic equation, that is 4n square plus 5n minus 636 equals to 0. Now finding the factors, we get n equals to 12 and n equals to minus 53 by 2, minus 53 by 2. But as we know that n can't be in fraction as well as negative, hence second case is impossible. Only possible value is n equals to 12. Now let us see next question. Question number 5 is, the first term of AP is 5 and last is 45 and sum is 400, means what is given? Sn is given 45, An is given 45, Sn is given 400, A equals to 5. Using this we want to find values of A, N and D. Now as Sn is given, we are first using formula for Sn, that is second formula for Sn, that is n by 2 in a bracket a plus l. L is nothing but an, which is given 400. Simplifying this, we have n equals to 16. Now secondly, to RHS we are solving an. We know formula for an, that is a plus n minus 1 into d, that is 45. Now simplify this further. After simplification we get d equals to 8 by 3, which is the required answer. Okay, now let us proceed. See question number 6. For this, first term and last terms are given, means a equals to 17, last term, that is an equals to 350. Common difference is given d, and how many terms are there, so that we want to find, means simply we want to calculate value of n as well as Sn. First we will use formula for an, that is a plus n minus 1 into d. Replace all the values known, n will be equals to 38. Now let us use formula for Sn. Here we are using second formula for Sn, that is n by 2 in bracket a plus l. Simplifying we get Sn equals to 6973. Now, seventh question. Find the sum of first 22 terms, means simply we want to find S22. What is given? D equals to given 7 and 22th term means A22 is given. Okay, that is 149. Now as A22 is given, we will use formula for an, that is a plus n minus 1 into d, means a plus 21 d equals to 149, hence a will be 2. Now Sn can be calculated by second formula, that is n by 2 in a bracket a plus l, that is 22 by 2 in a bracket 2 plus last term is given 149. After simplifying we get S22 equals to 1661, which is the required answer. Now let us solve question number 8. See, for this question A2 is given, second term is given 14, third term is given 18. Using this we want to find sum of 51 terms, means S51 we want to find. Now S2 can be calculated as a plus d. We know formula for an, that is a plus n minus 1 into d. Hence A2 can be calculated as a plus 2 minus 1 means d. 1 into d equals to 14. Secondly, we have A3 means a plus 2d. that is equals to 18. Hence, D will be 4. Now, replace this value of D in equation number 1. We have A plus D equals to 14. Hence, A will be 10. Now, Sn can be calculated as n by 2 in a bracket 2a plus n minus 1 into D. Replacing all the values, we have Sn equals to 5610. Now, let us see question number 9. Here, sum of first 7 terms of AP is 49. Means what is given? S7 is given 49. And that of 17 terms means S17 is given 289. Find the sum of n terms. Means firstly we are using S7, that is 49. We know formula for Sn, n by 2 in a bracket 2a plus n minus 1 into D. Now, simplify this. We have a plus 3d equals to 7. Let it as equation number 1. Now, secondly, we have S17 equals to 289. Again, replace the values for this. We get a plus 8d equals to 17. Let it as equation number 2. Now, combine equation number 1 and 2 both. After simplifying, we have d equals to 2. Now, replacing this value in equation number 1, we get a equals to 1. Now, let us calculate Sn. Sn, formula for Sn is n by 2 in a bracket 2a plus n minus 1 into D. That is, replace value of a as 1 and D as 2. That is, Sn will be n square, which is the required answer. No need to generalize, use the particular values of n, as it is not asked. Just we want to find general answer for Sn. Okay. Now, let us solve question number 10. Show that a1, a2 up to an dot form an AP where a is defined below. Now, if an is given, first bit we will solve first. An is given 3 plus 4, 9. Now, tell me what is a? A is nothing but first term. To get value of a, we need to replace n as 1. Hence, a1 is nothing but a. Let us replace value of n equals to 1 in the formula given. We get a1, that is a equals to 7. Second term can be calculated simply by substituting n equals to 2, that is 11. Find a3, that is 15. a4, that is 19. Now, find what is asked, show that it is AP. How this sequence will be AP? If we are getting common difference. Okay, and let us check difference of a2 and a1. 11 minus 7, that is 4. Now let us check a3 minus a2. This is also 4. Let us check a4 minus a3. It is also 4. Hence, all the successive terms have the common difference. Hence, this is an example of AP. Now, if it is an AP, then let us calculate value of Sn. Sn equals to n by 2 in a bracket 2a plus n minus 1 into D. Now, after replacing all the values, we have S15 equals to 525. Now, for second bit, an is given 9 minus 5n. Same for logic, substitute n equals to 1 to get first term. Hence, first term equals to 4. Substitute n equals to 2. Hence, a2 equals to minus 1. And for n equals to 3, that is a3, we have minus 6. a4, that is minus 11. Now, again check difference between successive terms as that of previous one. As all the terms are having constant difference, hence it is an example of AP. Now, for this AP, we are having a equals to 4, d equals to minus 5, n equals to 15. Hence, replace all values in Sn, that is S15 we get, that is equals to minus 465. Okay, now, let us see question number 11. If the sum of first n terms of AP is 4n minus n square means what is given? Sn is given. Now what is the first term of AP? How to calculate first term? Simply replace n equals to 1 in Sn. Hence we have S1 equals to 3. S1 is nothing but A1, that is equals to first term, that is A. Now to calculate second term, we need to replace n equals to 2. First, let us replace n equals to 2 in Sn. Hence, we have S2 equals to 8 minus 4, that is 4. Now, A2 will be second term. How we can calculate? Sum of first two terms minus first term gives second term. Hence, A2 can be calculated as S2 minus S1, that is 4 minus 3, 1. Now, let us calculate S3. A3 can be calculated as S3 minus S2, that is equals to minus 1. Now, what else we want to calculate here? Find third term. Third term we calculated. And 10th term. 10th term can be calculated as S10 minus S9. Replacing all values, we have A10 equals to, that is 10th term of AP equals to minus 15. Now, in a general, how we can get nth term? Nth term can be calculated as Sn minus 1. That is Sn we know. Now, how to get Sn minus 1? Just replace n by n minus 1. Hence, we have An equals to 5 minus 2n. Now, question number 12. Find sum of first 40 terms which are divisible by 6. Let us calculate all the positive integers which are divisible by 6. Starting with 0. 0 is not divisible. 1, 2, 3, 4, 5 are not divisible. Hence, we need to consider AP as 6, 12, 18, 24 till 40th term. Okay. Now, what will be the first term? Obviously 6. As all are multiples or divisible by 7, hence common difference will be D. That is equals to 6. 40 terms are given, means n equals to 40 is given. We need to find value of S40. We know formula for Sn. N by 2 in bracket 2a plus n minus 1 into D. Replacing all values, we get S40 equals to 4920, which is the required answer. Now, next question again similar one. Find the sum of first 15 multiples of 8. Let us write first multiples of 8, that is 8, 16, 24, 32 and so on. How many terms we want? 15 terms. Let us calculate A. A is nothing but first term, that is A. 8. Common difference, obviously all are multiples of 8. Hence common difference will be 8. Number of terms are 15, hence n equals to 15. Now, find value of S15 by replacing all the values in the standard formula for Sn. That gives 960. Now, 14th question. Find the sum of odd numbers between 0 to 50. Let us count all the odd numbers, that is 1, 3, 5 till. Now, from the end we need to go back. That is 50 is not odd number. Now, next odd number will be 49. Hence, last term is 49. Here we don't know value of n. We don't know how many terms are odd numbers are there in between 0 to 50. Okay, we need to calculate it. An will be your 49. Now use formula for An here. That is a plus n minus 1 into D. 49. Replacing all the values, we have n equals to 45. Hence, in all, 45 odd numbers will be there in between 0 to 50. Now, use formula for Sn. You can use either formula, first or second formula, but comparatively second one is easy. For that reason, I am using second one. That is n by 2 in bracket a plus l. Replacing values, we have 625. Okay, this is all about the question number 14. Remember now, for this academic year, next questions of this exercise will be omitted, that will not be asked for exam. Okay, for that we are not taking next questions. Till 14 only we need to solve. Okay, now at this point we can declare that this lesson number 5 is over. Now today you are solving this exercise 5.3 with question number 14. Okay, I hope you are getting this. Take care of yourself and your family. Bye bye.